Section 7.5 is about multiplying and dividing rational expressions. I don't mean rational, I mean radical expressions. So when we're multiplying radicals, we're going to need to FOIL or use the distributive property. Remembering that if I have the square root of 2 times the square root of 3, that's the square root of 6, right? We multiply what's under our radical sign. So the square root of 3 times the square root of 7 gives me the square root of 21. The square root of 3 times the square root of 5 gives me the square root of 15. And I have to check, can I simplify any of those radicals? And the answer is no. So for problem 2, we're going to use first, outer, inner, last. So we're going to FOIL. Hi, Bobby. 3 times 5 is 15. 3 times the square root of 2 is 3 square root of 2. Square root of 2 times 5 is 5 square root of 2. And the square root of 2 times the square root of 2 is the square root of 4, which is going to simplify. So I have 15. And I go ahead and combine like terms. I've got 3 square root of 2 and 5 square root of 2. That gives me 8 square root of 2. And the square root of 4, why do I keep doing that? Becomes a positive 2. So I have 17 plus 8 square root of 2. Let's try that again. I'm going to go ahead and FOIL. The square root of 10 times the square root of 10 is the square root of 100. If you want, you could just write down 10, right? The square root of 10 times the negative square root of 3 is negative square root of 30. Square root of 3 times the square root of 10 is a positive square root of 30. And the square root of 3 times the negative square root of 3 is negative square root of 9. So I have 10. My middle terms cancel out. Minus 3, because the square root of 9 is 3. My final answer is 7. Notice how these are the same except the sign, plus or minus. These are actually called conjugates, and we're going to talk about those more in a minute. And conjugates are really important because, as you can see, it got rid of our radical. We have no radical in our solution. Okay, for problem 2, I've got 2 square root of 5 plus 2 square root of 3 minus the square root of 7 times 5, which is 35, minus the square root of 21. And there are no like terms I can combine. I also can't simplify any of these radicals. So that's actually my final answer. So let's talk about rationalizing denominators. This means removing the radicals from the denominator of a rational expression. So on the list of things that make math professors say ew, number 1 is definitely trying to divide by 0. But a close second is having a radical in the denominator. So in order to get rid of the radical in the denominator, we multiply by the smallest radical possible to produce a whole number in the denominator. So let's take a look at this. If I have 3 square root of 7, I'm going to multiply by the square root of 7, again, harnessing the power of 1. So I get 3 square root of 7 over the square root of 49. So I have 3 square root of 7, 49. For problem 2, ignore the radical in the numerator. We don't care about that. We're focused on the denominator, which is the square root of 5. So I'm going to multiply by the square root of 5 in the numerator and the denominator. So I get 5 square root of 10. And I'm going to go ahead and simplify this. 5 square root of 5 times the square root of 5 is just 5. And then we could simplify my 5s. So the answer is square root of 10. Now, for problem 3, we're supposed to multiply by the smallest radical. You could multiply by the square root of 12 and then simplify everything. But let's go ahead and simplify the square root of 12. Remember that 12 is a 4 and a 3. 4 is a 2 and a 2. So we are going to have negative 6 over 2 square root 3. So the smallest radical to produce a whole number is going to be the square root of 3. So I have 6 square root of 3 over 2 times 3, which is 6 square root of 3 over 6, and again that cancels. So I have square root of 3 as my final answer. But what if I do if my denominator has a real part and a radical? Let's take a look at that. Actually, let's solve a few examples first. Then I'll tell you how we do that. So again, we want to go ahead and distribute that radical, right? I've got the square root of 18 over the square root of 125. The square root of 18, that's 9 times 2, so that simplifies to negative 3 square root of 2. The square root of 125 is 5 cubed, so I'd have 5 square root of 5. I'm going to go ahead and multiply in the numerator and the denominator by the square root of 5. And that'll give me negative 3 square root of 10 over 5 times 5, which is negative 3 square root of 10 over 25, and I cannot simplify that any further. For problem 2, we got some variables involved. That's always fun. So I have the square root of 50 m to the 4th over the square root of p to the 5th. My denominator is going to simplify to p squared square root of p. My numerator is going to simplify to 5m squared square root of 2. I know that's very exciting, Kat. And I need to multiply the top and the bottom by the square root of p. So I have 5m squared square root of 2p over p cubed. And I can't simplify this any further.